Hello and welcome to section 7.2 and 7.3. For today's video notes, actually it's not going to be as long as yesterday's was. I know yesterday was a long one. Today's going to be pretty short. We are going to cover section 7.2 and 7.3 together, but I'm going to hit the basics on the video so we can look at more of the hardcore stuff in class. So, good news about today. We're really building on yesterday's success. We are going to be graphing again. Yesterday we looked at what was called exponential growth functions. We did have that new word, that was the word since 30 but isn't. That's asymptote. We will have asymptotes again today, except for the big key connection today is we're going to be decreasing instead of increasing. So really kind of the same thing, parent-child functions once again. We're going to look at the parent function and we're going to make a child. Translations work the same way, asymptotes work the same way, and domain and range work the same way. So like I said, should be pretty light lecture today. Hopefully we're going to see how some things connect. Pretty straightforward stuff though, like I said. Lighter video. I think just 2 checkpoints today. And then we're going to go from there. All right. This is a sample of a generic parent function. This is straight out of the textbook from 7.2 on page 486. Really want to just emphasize the differences for exponential decay as opposed to exponential growth. First off, we still have that asymptote. In this case, it's going to be at 0. The shape of the graph is very similar. However, it's going down, decaying, instead of growing. This will be an example. Growing is what we did yesterday, and we would grow up as s got bigger. As x got bigger, we grew up, and today we're going with decay. X is going to get smaller. Okay? So exponential decay is what we're looking at. Today, for exponential decay, we only need 2 values for the parent function. So we'll talk about domain and range. Domain is, again, going to be all real numbers. And your range is still going to be restricted by that asymptote. In this case, y is going to be greater than 0. I don't expect you to copy all this down into your notes. The next problem I do expect you to copy down into your notes. So this is just kind of a heads up about where we're going, and now we're going to get into the actual example. First thing we're going to look at, y equals -2 times 3 to the x, 3/4 raised to the x. Wants us to graph the function, state the domain and the range. Graph it, state the domain and range. Play doctor. First thing, as we look at this, hopefully you'll agree with me, there's not any changes for the x values. No opposite x's on this one. For same y's, we do have one change. That is a multiplier by 2. There's no other translation change for the y values. So, we'll start with the parent function. As I said, for exponential decay, I'm only going to ask you to do 2 points. Identify your parent function. In this case, it's the easiest form of the function. Y equals 3/4 to the x. Y equals 3/4 to the x. And then we're going to go ahead and get our, we're going to make our child function as soon as we get the parent function down. Values for x that I want you to use here, 0 and 1. Why? Because they are super easy to use. So y equals 3/4 raised to the x. That is the same thing as saying y equals 3/4 to the 0 exponent. And if you remember that anything to the 0 exponent is 1, that's a property of exponents. So 3/4 to the 0 is 1. Okay? The other coordinate is also easy to get. Y equals, let's see, that's going to be 3/4 to the 1. Well, 3/4 to the 1 is just 3/4. That's it for our parent function. That's all we got to do. Next up, make the baby function. As I already told you, there's no changes for the x values on this one. There's no opposite x up there. It's just x by itself. So I have no changes for x. So it just gets me to 0 and 1. My y changes. The y changes are multiplied by -2. So my y change is multiplied by -2. So the first change I have for y is 1 times -2 for -2. Then I have -2 times 3/4. Well, -2 times 3/4 is what I have to do. That's -6/4. Some of you guys reduce within that. That's fine. We're going to divide out a factor of 2 there. Comes to -3/2. So there's my two coordinates that I need. Once again, our asymptote is dictated by our change in y. In this case, we don't have any shifting of y, so our asymptote will stay at 0. In the next example, we will have a shift of the asymptote. Again, make sure you're agreeing with me when I say, hey, we don't have any change in y, besides the multiplier thing too. I'm talking about the HK stuff. All right, plot these points. 0, -2. 0, -2. Let's use daisies today. 0, -2. And 1, -3/2. -3/2 is -1 1/2. So 1, -1 1/2 is right there. At this point, that's enough to draw my curve through. We will head at one end towards that asymptote, and the other end will head up. So we're going to look like this. Okay. And that's all we need for exponential decay. Domain and range. Once again, I can put anything in for x that I like, so we have all real numbers. We do not have a domain restriction. We do have a range restriction. The range is always dictated by where our asymptote is. The green line is our asymptote. That's at 0. In this case, my y values are lower than 0, not greater than 0. So y can be less than 0. That's it. And you should see a lot of similarities between today and what we did yesterday, which was graphing exponential growth. So, real straightforward stuff today. Like I said, next thing up is a checkpoint for you guys. So go ahead, pause the video, get that problem done. That's what I expect to be on the green paper when you come in to start a class tomorrow. Pause the video, do that problem, unpause the video, and we'll go to the next problem. All right, time for the next problem. Whoa, that's a lot of information. Again, this can be found on page 486 in your text. I don't expect you to copy all of this down. Don't worry about it. I just want to talk about it as we're looking at the generic form here. Notice that once again, opposite x is what we're going to deal with. Same y is what we're going to deal with. We've got a multiplier here, and then we've got a change or a translation here for k. Also, this change for y will tell me where my asymptote is. All I'm asking you to do is two coordinates. Two coordinates. All right? Here's how it's going to look. Looks hard, but isn't. Y equals 2 times the quantity 3/5 raised to the x minus 1 plus 1. Again, y equals 2 times the quantity of 3/5 raised to the x minus 1 plus 1. Graph it, state the domain and range. As I told you, for these problems, your parent function is always the easiest form of the function. Y equals 3/5 to the x. That's the easiest form of the function. So, two values we're going to use are 0 and 1. Anything to the 0 exponent is 1. 3/5 to the 1 is going to be 3/5. Those are my two coordinates for the parent function. Child function on this one is going to have a fair amount of change. My first change is going to be in my x values, and that's going to be opposite x. I'm going to add 1. 0 plus 1 is 1. 1 plus 1 is 2. That takes care of my changes for the x. Now I'm going to look at the changes for my y's. First change for the y is a multiplied by 2. And the next change of y is same, is plus 1. So every value will be multiplied by 2 and then added by 1. So my y value, 1 times 2 is 2. 2 plus 1 is 3. My next y value is 3/5 times 2 over 1, which is 6 over 5. And then I need to add 1 to it. Well, the way that I'm looking at this problem, I'm going to make 6 over 5, 1 1/5. I'm going to add 1 to it, which is going to give me 2 1/5. Another way to see that is 6 over 5 plus 5 over 5, which gives you 11 over 5, which is also 2 1/5. You get the same answer either way. So I'm going to write down 2 1/5 for that value. Okay? I'm going to plot the points. I think I'm using today's. So we've got 1, 3, 2, 2 1/5, which is going to be about there. Now I need to graph it. I need to cover my asymptote up. So hopefully you agree that your asymptote will be that shift. So my asymptote here will be at positive 1 on my y. My asymptote will be at positive 1 on my y. Connect the dots. This is one curve. It'll start high and go low. And that's all we need. Domain and range. X is all real numbers. And my range this time, you tell whoever's looking at your problem what the y values can be. Hopefully, you'll agree with me that the y's are above the value of 1 in this case. So y is greater than 1. Once again, your range is given to you by your asymptote. All right. That's it for that problem. Next problem up, checkpoint for you guys. Sketch the graph, domain and range. That's all you need. Bring that completed at the start of class tomorrow. And actually, believe it or not, that's it for this video. So get this checkpoint done. Make sure you're comfortable with how these translations work. See how it's the same. See how it's different from exponential growth versus exponential decay. And then we'll come in and actually work a lot on growing some money in class. Okay? So that's about it for me. I will see you guys tomorrow.